All right, so in this lesson we're going to talk about dilation and actually how to dilate a figure. So this is our last transformation, and this is not a rigid motion. So dilation is, I'm going to write that, not considered rigid. And that is because it changes size. So anytime you dilate a figure in mathematics, it means you are making the figure bigger or smaller. Or you could say larger, smaller, or any synonyms for that. But dilating basically just means I'm going to take the original figure, I'm going to either make it bigger, I'm going to make it smaller. If you think about, I always think about going to the eye doctors, they dilate your eyes, they make your pupils really big. So that's just kind of the same thing. So in order to dilate something, you need to know two things. You need to know the center of dilation, which in Math 8 is always 0, 0, or the origin, we call it. Okay, and you need to know the scale factor. The scale factor tells you how much to dilate your figure, so that way you know how to multiply and everything like that. So what actually is a scale factor? A scale factor is a number you will multiply each coordinate point by. So say your scale factor is 2, that means you're going to multiply every coordinate point of your original shape by 2. So I kind of just answered this question here. That's going to mean you're going to take your factor and multiply it by each coordinate point. Okay, one thing I did forget to mention, it's important to know that if your scale factor is greater than 1, your figure will get bigger. So greater than 1 would be like 1.5, 2, 2.5, 3. Because if you're multiplying it by 2, that really means you're doubling everything. So you're going to naturally just get bigger. If your scale factor is less than 1, your figure will get smaller. So for example, less than 1 might be 0.05, which is the same thing as a half, right? So if I take a half of something, it's going to get smaller. You could do 0.25, which is a quarter, 0.75, which is 3/4. Again, you can make those numbers into fractions, which is making it smaller. Okay, so those are really the main points of dilation. Dilation is actually really easy. The thing that you need to know is the points before. So let's look at a couple examples to make sure that you're able to dilate a figure. Okay, so first we're going to look at example number 6. So to do example number 6, it says graph the dilated image of the triangle XYZ. So we see triangle XYZ, that's the pre-image if we're going back to our intro video, and it says using a scale factor of 1.5. So that means because that number is greater than 1, this is triangle, we can expect to get bigger. Okay, and 0, 0 as the center of dilation, that's always going to be the case for Math 8. So I just want to obviously make sure that's true, but I don't need to worry about it. So the first thing you're going to do is you're going to write down the points of the original pre-image X, Y, and Z because you need to have the points in order to dilate. So X is going to be right here, so it's -4, 2. Negative. And then Y looks like it is 6, 0. And then Z looks like it is -2, -1, -2, -3, -4, -2, -4. And now that I have those pre-image coordinates, I can actually just take each coordinate and multiply it by the scale factor. So I'm going to take -4 in x, and I'm going to multiply it by 1.5 using my calculator, and I'm going to get -6. And then I'm going to take 2 and multiply it by 1.5, and I'm going to get 3. And then I'm going to take 6, and I'm going to multiply it by 1.5. I'm going to get 9. And then I'm going to take 0 and multiply it by 1.5. I'm going to get 0. And then z prime will be -2 times 1.5, which is -3. And -4 times 1.5 is -6. And so then once I have them, I can plot them on my figure and I should see, or my screen, and I should see a bigger triangle. So I'm going to do it real quick. -6, 3. You can already see that that's x prime, which is clearly a little bit bigger than x. Y is 9, 0, which is right here, bigger than y. And -3, -6, 1, 2, 3, 4, 5, 6 is all the way down here. That's z prime. And I'm just going to do my best to connect them so I don't run out of time here. But if you see, it's clearly a bigger triangle than what we had before, which is exactly what we predicted using that scale factor. Okay, so that is one example of dilation. I'm going to show you another example of when it gets bigger, and then I'm going to show you an example that when it gets smaller. Okay, so for this one it says dilate triangle ADI, which I'm going to actually change to ABC. So if you notice, the triangles ABC and the coordinates after the dilation are A prime, B prime, C prime, so I'm just going to stick with ABC. So A is -1, 1, and you would plot those. I already plotted those for us so we can make sure we can get moving. So it says multiply by a scale factor of 2 from the origin. So again, our center of dilation is the origin, and we're having a scale factor of 2. So that just means I'm taking each point and multiplying it by 2. So if I have A, which is -1, -1, I'm going to multiply them both of those numbers by 2. So I'm going to get -2, -2. Then I'm going to take D and multiply 0 by 2 to get 0, and 2 by 2 to get 4. And then C, I'm going to 3 and 1, I'm going to multiply 3 by 2, which is 6, and 1 by 2, which is 2. And then I would, again, just plot the figures there, and I should see it get bigger by a scale factor of 2. So -2, -2 is right here. So that is A prime. And then 0, 4, that is B prime. And 6, 2, that is C prime. And then I'm just going to connect my dots here the best I can on the computer. And if you look, it looks like that triangle got bigger. Okay. So that's how you dilate a figure. You won't have to graph it, but you'll definitely have to be able to find the image point. So A prime, B prime, and C prime. You'll definitely have to do the calculation. So what are the important pieces of information given for dilation? So in any dilation, even when you get to geometry, you're going to need to know the scale factor and the center of dilation. Those are the two main things you need to know whenever you're dilating. The center of dilation for us will always be 0, 0, or the origin, but the scale factor is going to change depending. So when you get into geometry, your center of dilation will change, but for now you just need to know how to do it with 0, 0. Okay, and then the last example I'm going to look at is I'm going to actually make this smaller. So it says dilate triangle XYZ, gives me the coordinates by a scale factor of 1/2 from the origin. So 1/2, this means it's going to get smaller because it's less than 1. Okay, 1/2, and I can't. 1/2 is less than 1. Okay, So the first thing I'm going to do is I'm going to take that 1/2 and I'm going to look at my original points. So the easiest way to do this is to take your calculator, and you can do -4 for the x coordinate and multiply it by 1/2. So you could either use the decimal, because 1/2 is easy to change into a decimal, you could use 0.5, or in your calculator you can use 1 ABC, the button ABC 2, and that is the calculator's way of writing fractions. So you could do, I'm going to use 0.5, so 4 times 0.5. If you had to use a fraction, just make sure you use the ABC button on your calculator. Okay. And also at 1/2 is easy, so I can just say, okay, what's half of these numbers? So I can say, okay, what's half of -4? Half of -4 is -2. Half of 0 is just 0. Half of -4 is -2. Half of 4 is 2. Half of -2 is -1. Half of -2 is -1. So again, you could just do it that way too. But you are multiplying by 1/2 and not dividing, just to be clear. So multiplying always. Okay, so now that I have the original or the image points, I'm going to go ahead and plot them. So -2, 0 is right here. So that's x prime. Y prime is -2, 2. Up here. And -1, -1 is right here. That's z prime. And so if you look, it's going to be a little triangle. But it's definitely the same shape but smaller. Okay, so we just did a dilation that made it smaller because the scale factor was less than 1. So there's 2 examples of when you dilate a figure to get bigger. Both of those scale factors were greater than 1. And an example when you're dilating smaller. This had a scale factor less than 1. So you always just want to multiply whether it's bigger or smaller. Okay? All right, if you have any questions, reach out to your teacher.